I'm Nick Sipes. I've been in the background of this thing since the beginning of it. At CAD Microsystems, I'm one of the Revit consultants, specialists, problem solvers, as I like to think of myself. And I worked doing commercial interior design for like 10 years before coming to CAD Microsystems. Most of that doing large government projects down to small little tiny office renovations, between Revit, AutoCAD, everything like that. And oddly enough, you'd think that coordinating with like civil and share coordinates wasn't a big thing. And it wasn't huge for me in that time, but I was kind of the one that was responsible for making all the Revit models talk to each other. So I did end up having to figure all that out. And then fortunately, once I came to CAD Microsystems, we have wonderful people here that have backgrounds in civil engineering, like Marissa, who I will let her talk about her background. If I can ever change the slide. There we go.
Microsystems, as you've heard a couple of times, and I am the practice manager for the civil infrastructure team. I have worked for another number of different companies doing civil engineering, surveying, GIS. I have sort of an eclectic background like that. At CAD, I do a number of trainings, seminar, a lot of different types of consulting projects, and I specialize in mostly Civil 3D, but also AutoCAD, Map 3D, even Land Desktop, which is really old. But I was here basically to work with Nick, and it was a really wonderful thing because, you know, sometimes architects and engineers just don't get along, but Nick and I get along great, so yay.
So that's a really quick synopsis of the two of us, and we kind of teamed up to figure out some of the issues of coordinating between civil engineering and Revit. And one of the things that a lot of people say incorrectly is Revit doesn't understand coordinates. And it's not that it doesn't understand coordinates, it's that most of the time we don't understand what it wants. And the fact is it's a software that's designed to handle not only a building being located in one place, but theoretically you could put that same building in several locations, which that just is really confusing to most people. But the other thing is that people say Revit doesn't understand GIS coordinates, which is mostly true. It doesn't, not without the help of Civil 3D. So you can see on the image here that that's the location panel straight from Revit, and it actually knows a GIS coordinate system code. Most people didn't even know Revit can do that, and it inherently can't. It has to get that data from a Civil 3D file. And so our course, which is like an hour video on AU, basically walks you through about making sure the Civil 3D file is set up to give the data to Revit, make sure the Revit file is set up in order to receive that data. And then once you've got that connection established, being able to send that data anywhere. And I do mean anywhere. It's not just Civil 3D. We talk about getting the data into InfraWorks. We talk about taking that and putting it into Navisworks, because once it's in the same coordinate system, it can talk to anything in that same coordinate system, whether it's Navisworks, point clouds, whatever. And that's the big thing of trying to get your building set up. And so, you know, this course, it required a whole bunch of things. One of the things that we showed in this course, which used BIM 360, was the linking of topography from Civil 3D into Revit, which can only be done using BIM 360. There are other ways to get topography between Civil 3D and BIM 360. You can use Land XML. You can do these things. What's interesting about this is that it natively reads a DWG file straight from Civil 3D and interprets it. And so, and it acts like a link, like any other Revit link. So if it updates, it automatically updates in your model. And we broke it down into steps. The first step is we have to accept a few things. that there are essentially two coordinate systems inside Revit. There's the real world, which Civil lives in, and like point clouds live in and everything like that. And then there's the project world. They have to hand off information between the two. You've got to establish the coordinates. Revit has to understand what the coordinate system is, and the only way you can really do that is to acquire it from a Civil 3D file. And then once you've done that, you can start synchronizing data. You can send a 3D building to Civil. You can get topography from Civil into Revit. And then you can also send everything into InfraWorks to get a big picture. And so that's kind of what this course focused on, was sharing of the data and getting it all set up right. The first thing, which Marissa took care of this slide during the presentation, so I'll let her handle it right now.
Yeah, so as Nick said, the first part of this is acceptance and allowing, us to work together by accepting each other. And the first thing is for civil engineers that are, actually, let me back up. It's telling, we're trying to tell each other how we both work, okay? So for the civil engineers, we need to understand that the buildings are rotated so that they fit on a piece of paper. They don't really care where they are right now. They're just trying to put it on a piece of paper to create construction drawings. So we as civil engineers need to be okay with that. But on the same token, architects, you've got to realize that the world is round and it doesn't revolve around your building, at least not in our world, because we have to work with the stuff that goes outside of the building, and it's in, conjunction with all the other things, and they all need to come together in the right location. So we really need location. And we use sort of grids, and that's the coordinate systems to locate these items, your building, the roads, the surrounding pipes, things like that. We're mostly using state planes. So for those of you not familiar with this, each state has been broken down into a series of areas that can fit, can sort of be laid out on a flat piece of paper as well as possible. Basically, we have a circular earth. Nick, I think if you hit the next one, it should show the little earth thing that we had. There you go. Excuse me. So if you have this circular earth, it's difficult for us to take like a giant piece of paper and try and wrap it around the earth. It doesn't work. It crinkles. So it's been broken down into these smaller areas, and each smaller area has its own origin. It's got its own coordinate system, and that's how we keep coordinates and keep it as accurate as we can. So next slide there.
Yeah. Yes. All right. So the inside Revit, to kind of transition what Marissa said into Revit speak, there's three coordinate systems inside Revit. And this is sort of like the first thing I like to tell people is like a lot of people said there's three origins in Revit. No, I don't know who started that. No, there are not three origins. There are not three origins in Revit. There is really one origin, which you couldn't see until a few years ago unless you linked in a CAD file. Arguably, the project base point's an origin, and I'll get into that. And then you have a survey point, which people said was an origin. It is not an origin. It is a reference point. And then sort of you have three coordinate systems, although really I only like to think that you have two. The first one, which I kind of go and not mention, which is the internal coordinate system. Basically, this is the mathematical grid that all software has to have that does anything, even two-dimensional. In this case, we have the 3 dimensions that you have to have in order to just make things work. Then you have the project coordinate system. This is what sets up, your project north, east, west. By default, all of your views in Revit are set up this way, and there's a reason for that. Out of the box, this is what's important, because until you've talked to somebody, you have no idea where your building is going. I don't care if you've looked at a civil plan and you've read the civil file and you think you know where it goes. You can get close, but until a civil engineer gets involved, and you might be able to get the X and the Y down, but until you get a civil engineer involved, the Z is really tricky. And so it has to be a collaborative effort. And the designers of Revit realized this and said, okay, you know what? We're going to create a system that lets architects put it how they want to. And then the in the coordinate system we're going to make that coordinates it with the real world, the shared coordinates, that's going to be a reference. It's not a real grid. It's just a reference that says, okay, at this project base point lives at this real world coordinate. And that's how it really works. And so that's kind of the way this is set up to show, is that the orange is the project coordinates, the blue is the shared coordinates. And I always say leave the project coordinate or the project base point and the internal origin at the same point, and make it a point that's easily identifiable on your building. There's arguments that can be made to move the project base point away from that, but and then the big thing to know is that internal origin, that's where that 30-mile radius that's not really a radius, that's not really 30 miles limitation comes from. So anyway, all right, we're getting a few questions coming in. I'm going to see. One of the questions was, is there a manual input? I'm guessing that's for the GIS coordinate system, and the answer to that is no. I can't tell you how much I wish there was a way for you to manually enter that inside Revit. Up until Revit 2018, you couldn't even put it in Revit. So someone's asking, do you share coordinates with civil engineer? So the shared coordinates, this is where we start getting into the demonstration, which we don't have time for. But yes, in a perfect world, your shared coordinates inside Revit and inside between all your building files are the same as the one with the civil. What's nice about Revit is actually you can set up several shared coordinates in one Revit file. So if you have to, and I'm not saying this is a good workflow, but if you have to have one set of coordinates for, say, the contractor who did their point cloud in one coordinate system without looking at what coordinate system the drawings were in, you can set up the two coordinate systems, and because it's just a relationship, Revit just switches which one you're looking at. So in a perfect world, everyone's on the same shared coordinates. In the real world, that's the joy of Revit, is it's designed to be able to handle multiple shared real world coordinate systems. So
Nick, I think, did we have, after that demonstration slide, I think there was another one that listed off the steps so that we can at least talk about the steps.
Oh, there
there it is.
Yeah, there we go.
Right there.
So it's very similar to the first step. And then, yeah, so the first thing was we all have to accept that
we got to work together.
We got to work together. And in a perfect
together.
world, we all have to agree on one coordinate system that works for everybody. Whether it's a state plane, if you're outside of the US, it could be something else. But I know most of the people here are within the US. Do we want to do that poll to find out?
There were some, and I saw someone from Canada.
Yes, and if you are calling from outside of where the survey is actually asking, I know a lot of you have already. I saw a lot of locals. Then please let us know in the chat where you're calling from. I saw some Colorados, both Colorado Springs and Denver, a few Denvers, some Canada, Seattle, Washington. That's awesome.
Yeah, that's pretty great.
So definitely let us know. Let this survey go for a few more minutes, and then we'll also ask you which discipline. Hopefully we have that one in there. So, and let's share the results here. So it looks like a lot of us are local, right? Maryland, Virginia, and North Carolina, pretty evenly split, almost exactly evenly split, but a lot of other states not listed. So we might need to increase this list somehow. It's pretty awesome, you guys. I love the reach we're getting.
I was gonna say we got
Michigan,
a few people out of the US. That's awesome.
Yeah,
that is
that's
very,
cool.
very cool. All right. And so let's.
So I'm gonna jump back into just answer these really quick questions. So let's not forget that civil engineers derive the XYZ data from a surveyor. So yeah, once again, we all have to talk.
Yeah, we didn't even put in the part about the civil engineers working with the surveyors. That's its own sort of animal sometimes. And having been on both sides of it, it's definitely an animal sometimes. But to be honest, we agree that we're not that happy with you guys sometimes. But, you know, that's how we sort of bond. So that is absolutely important. I mean, the surveyors are the ones that are going to establish, you know, where the existing part is and where the, you know, where the site is in the world. And then we are the ones that have to decide where the building is going to go on the site. And then, of course, we hand that. So, you know, basically Nick will hand me a floor plan, or basically a floor outline, and I stick it into my site and rotate it and put it in the right place. And then I'll have to send him coordinates of, you know, whatever his origin was. So he's going to tell me what his origin was, and I send him the coordinates and the elevation of where I think that should be. Then he can take that basically back into Revit, and that's where he can then, that you do have to manually type in, right? Those coordinates have to be manually typed in?
Yes, the way we showed it.
Okay.
You could also use an add-in, free add-in from Autodesk. You need one on both ends. So Civil 3D needs to be able to install it, and Revit needs to have it installed. I think they're both now finally have the same name, called the shared reference point. Essentially what that does is it manually, or you click some points and it fills out a text file, and then in Revit you select that text file and it fills in the data. So we showed it without that add-in because there are some people that can't install add-ins.
Yeah.
And because I know that add-in was shown with another presentation that's on AU. So I was like, well, I want to show another way of doing the same thing.
I'm going to actually show it in a little bit.
Oh, yeah. Well, there you go.
Yeah.
There was Dan Warren had 2 points. One that I love and I don't know how to solve, but is that he sees projects with Project North. So when you start modeling, you model everything skewed as if you were modeling to True North. Don't do that. Bad.
It looks like we have another question. How much easier it becomes to have a shared coordinate system in a campus environment, and sharing that with your contractors for that campus?
So before I fully understood this personally, is one reason. I used to think you'd have to have a local point that you would use. And that's where moving the project base point away from the internal origin might make sense. Is that you use the internal origin as the local point for a whole campus, and then you have project base points for each building in there. A lot of time when you get to that kind of setup is you end up with one Revit file that's the site Revit file, and that's the one that's controlling the coordinates for everybody.